So let's think of another point, right? So you said pressure is mass. The two are interchangeable. And then we're always talking about wind, right? When we're talking about the simulation tool, you can adjust the wind speed. We're talking about wind being an integral part of quantifying the emissions of these facilities. These are things that we think are obvious. And oftentimes when I'm talking to folks, especially when I'm brought in to be like a guest for an undergrad class or something like that, it gets down to really what is wind. And oftentimes I explain to folks that wind is actually a form of solar energy. And their mind is blown in many cases. And so one of the things that's actually happening that I don't think people fully understand is that what the solar receipt, the solar coming in to the Earth's atmosphere is causing is a change in pressure in the atmosphere. And these molecules, these balloons in your hand, flow from a high pressure to a low pressure area. And more or less, that's a vast oversimplification. That's what's happening with wind. And so help sync up for people what is actually happening between mass, pressure, wind, and how these things fit together in terms of a transport model, which we'll talk a little bit about as well, I'm sure, given that's foundational for a lot of the work that we're doing. How should people start thinking about some of these pieces in terms of the different fluids that exist in the atmosphere, how these fluids actually interact with one another? For instance, you mentioned that methane is lighter than air, quote unquote, but truly it's lighter than the weighted average basket of compounds in the air because there's CO2 in the air. It's lighter than that, but it may not be lighter than some of the other things that are in the atmosphere at any given point in time. So I think it would be helpful to start syncing up some of these points for folks.
The for me at least, going back to atmospheric dynamics, the easiest way to think about wind is actually to just keep thinking about mass. Don't think about pressure, because pressure is an interesting quantity, and there's a reason why that quantity exists, and that it has a historical significance, because 300 years ago we used barometers to measure this thing, and we could, but in the end it all comes down to mass and continuity and the conservation of mass, right? This is where wind comes from. If for some reason say these two balloons here together represent a continuum of air, which is how we think about gases and fluids. We think of them as being a continuous blob. So this has to do with some of the mathematics involved. We know that that's not true. We know that there are molecules involved and space involved between those molecules, but there are so many of them in bulk that we think of everything as a continuous substance, right? So let's imagine that for some reason, and in this case we'll say that the reason is the heating from the sun. Because of the heating from the sun on this balloon over here, on this chunk of air, for some reason the sun heated it, and now it moved itself spontaneously up here. Well, what happened to the space that it occupied before? Did it turn into a vacuum? No, right? That would require a significant amount of energy to do that. That would be really, really difficult to do. What happens is that other masses of air have to rush in to fill that void. And if that keeps displacing up, then other masses of air have to follow. And what happens is, in the atmosphere, as masses of air are moved spontaneously by energy, so now we have to talk about mass and energy. And this is all we ever talk about, mass and energy. And they're interchangeable and so on and so forth, but it is the addition of energy onto mass that causes it to displace spontaneously, that causes other masses to have to move into that space in order to find equilibrium. And in doing so, look what happened. I moved one, the other moved horizontally. This is wind. Wind happens because of continuity, and it has to be that way. There is no other possible way that the atmosphere can manifest itself. And this is why when we talk about atmospheric flow and wind, we talk about circulations of wind, and this is where the circulations come from. And you see that manifested in simulation in our tool. You see that when the animation is playing, you'll see the animation being broken up into what we call eddies, vortices, and elements like this. These are small circulations, and these circulations obey the conservation of mass.